Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
in this rational equation here, we actually have three terms. So this is not a proportion. So there's a couple of ways we can do it, and honestly, it just depends on what's given to you. Hopefully, immediately you recognize the denominators are all the same. So the easiest thing to do here is to combine these two fractions here since they already have a common denominator, and then that would set up a proportion because we are total pros at solving proportions. Okay, at this point now, we're ready to find our restrictions. We have our restrictions. Let's rewrite our proportion and get to work. Now, we get x equals 1. Let's cross-check it up here. We can see x can't be 0. This is not a restriction, so now we know x equals 1 is our answer. In this rational equation, again, there's three terms. However, do you recognize that the denominators are not the same? That's not a problem. We can handle that. The first thing we still need to do, though, is find our restrictions. So in this particular case, all the denominators give the same restriction. For this problem here, now that we know what our restriction is, we need to look at our common denominators here. Well, none of them are in common. However, they all have an x squared, so that really is helpful here. So what we want to do is combine two of them on this side here into one, and then we can do our proportion. So I'm looking at these two right here, and I'm recognizing they both have an x squared, which is pretty sweet. However, that coefficient is 2, and that coefficient is 6. But I can modify this middle fraction so it looks like a 6x squared. So I'm going to rewrite my equation, but I'm going to leave a little bit of space next to this middle fraction so I can modify it. So I've done two steps in one here. I wrote 3 over 3 to demonstrate that I'm going to change 3 times 2x squared to make it 6x squared, because that's the common denominator for the first two fractions here. And in the same step, I also rewrote this now that these two have common denominators as one fraction. Before I go ahead and try to do any inverse operations, I'm actually going to simplify the numerator. Now, it doesn't matter that these denominators are the same. All I'm going to do now is the cross product. At this point now, what's going to happen is I'm going to distribute my 3x squared into this binomial here, and then I'm going to combine like terms to one side and solve from there. So we have two possible candidates as our answers. We have x equals 0 and x equals -2. Now, let's check what our restrictions were. Our restrictions said x cannot be 0. Uh-oh, wait, that means this x equals 0 cannot be a solution. That means x equals -2 is our only answer.